Welcome to Math Basics, Mr. Besh again. Today's a special day because now what we get to do is put all our knowledge that we've been working on from geometry on area, quadrilaterals, triangles, and circles, and put it to work. See, today we're going to have an abstract figure. We don't know the shape of the figure, nor is there a certain formula to calculate its area. So what we're going to do is we're going to break this into a bunch of parts. Then we're going to calculate the area of each of these parts, and then we're all said and done. We're going to find its sum, and that will be my area of my abstract shape. This is the picture that we're going to use today. This is the picture that was in the homework and that we started in class. As you can take a look, we don't know any formula to calculate the area of this, but this doesn't mean that we can't break this figure down into a bunch of tiny pieces. Just getting started, a few things I want to point out about this screen. Notice that I've already started to break this down into shapes. I have three of them. I have a rectangle, I have a triangle, and I have a semicircle. Now we know how to find the area of a rectangle, and we know how to find the area of a triangle. But a semicircle is something that I wanted to point out. You see, when you find the area of a semicircle, you treat it just like a circle, but at the very end you divide it by 2. So now the area of region 3 is going to be pi r squared, which is pi times the radius is 1 block, so 1 by 1, so pi times 1, and then we divide this by 2. So the area of that third region is going to be 1.57 units squared. And then we would calculate the area of A1, calculate the area of A2, and notice we have a little bit more work on this page. There's a little bit more room that we have to actually break these down into shapes. A trick is to break them down into as few shapes as possible, making our shapes larger because it saves us the math later on down the road. But the great thing about this exercise is that everybody in the class can have a different breakdown, and you could all have approximately the same answer. When we're all said and done, our answer is going to be a very close approximation. Now, what I want to talk about is I want to talk a little bit about measuring. One big common mistake that students make is they actually measure the length in blocks, and that's not the case. You measure the length of the block. So down at the bottom, from this point right here over to this point right here, a lot of students say that this is 2.5 because they're assuming this part right here is half of a block. That's incorrect. When we measure a length, a width, a base, or a height, we go from where we start right here, and then we count our blocks this way. 1, 2, 3. So now the measurement of my base of my triangle here is going to be 3. And then when we do the height, we do the same exact thing. Where do we start? Where do we end? And count the line segments as we go. And that's going to end up getting me 4. Sometimes you get abstract shapes that look along the lines like this. And students freak out because they don't know exactly or directly how to break this thing down. Just take your time. Break it to as many little shapes as you can. If you get a really bizarre shape, then you got to go to our friend the trapezoid. And I know sometimes students tend to shy away from that shape, but it's a very useful shape when breaking these things out. Notice that what I did, I ended up breaking that into a triangle and 2 trapezoids. Now, when we do the triangle, notice when we find the area of a triangle, we need its base and its height. Remember again, the height of a triangle is never a slanted or diagonal side. The height of a triangle is always perpendicular with its base. I have the height here highlighted in green for us, arrows pointing to it, as well as the base. Now, when I do my height and my base, and I calculate this, remember I go from one end of the triangle to the other. So now I go from here, and that's going to be 1, 2, 3, 4. So my base of my triangle is 4, and then my height is 1, 2, 3, 4. Check it out. A triangle that has a base and a height the same, both 4 by 4. Before I do any area formulas, before I calculate anything, before I punch one number into my calculator, the first strategy to do is break this figure down and label each region. Noticing mine? I used 13 regions here. Labeling start with A1, A2, A3, A4, 5, 6, all the way down to 13. Now, once I have all these regions labeled, what I do next is I take them, I pull them down, and I calculate the area of each. This was my answer key that I left in class. This is one where I broke it down into 8 regions. This was helped by a student. Students said, can we do it this way? And I said, absolutely. Your picture is exact. This is what I want to see from all my students. Notice that they broke it down into 8 regions, where mine up here, this was my creation, I broke this down into 13. And the neat thing about it is these 13 that I broke it in, And then these 8 that the student broke it in, we both got nearly the exact answer. This was work by the student. They broke it down. Notice that they had each of the shapes labeled, A1 all the way down to A8. They included the formula on how to calculate the area of each of these, and they even described what the shape was along the side. All this labeling helps out in the final product when we're all said and done. And then in this, notice that my area came out to be 98.35 centimeters squared. This is what I'm trying to do. So this was the lesson, this is what we did today, and this is what our next test is going to be on. I hope you found this lesson helpful.